Okay, picking up on 21, this should be the last video. So we have a table here. It basically wants to know which of these model types here, so which one of these guys right here is going to match my guarantee to pass through all my points that I have in my chart, and going to pass through all the numbers in my chart, and then because of that, which one of these do I choose? Well, a thing to remember is you always need sorry, it's been a long day of work. So you always need one less degree than your number of points in regressions. So how many points do I have here? I have 1, 2, 3, 4 points. So 4 minus 1 is 3. Therefore, I need a cubic function, okay? So basically, if I have a cubic function, I can fit up like 4 points. Then here, for example, I would use a linear if I had 2 points. That would be the smallest function I could fit that in, okay? So here, because I need cubic, my predicted x value at x equals 2.5 would be 9.125. So you always need one less degree than your number of points in regressions, okay? Then on 22, 300 liters of water and 7 kilograms of sugar were added to an empty tank, and then starting at time equals 0, t equals 0, additional water is added to the tank at a rate of 9 liters per minute. So this is water, and then sugar is added at 1.5 kilograms per minute. So which of the following gives it, like, it shouldn't say which of the following, it should say write a function or expression that has the kilograms per liter concentration. So for concentrations like this, you're like, what in the world? This isn't chemistry class. It's simple. I'll give this part to you. So for like a sugar water concentration, it's going to be your amount of sugar divided by water. Okay, pretty simple. Just sugar divided by water. Sugar divided by water. Okay. Well, this leads me to how much sugar do I start with? I start with 7 kilograms. Okay. So 7 kilograms. So I start with 7, and I start with 300. Boom, 7 and 300. And then from there, it just says I'm adding 9 liters of water per minute. So plus every time equals t, a minute. Every minute, I'm going up by 9 on my water, and I'm going up by 1.5 on my sugar. Okay, so you're just setting that up. That's all it wants. It just wants you to know, can you translate this to an expression? So it's just sugar over water. Then the last one, write a function that has the following features: a hole at 1, vertical asymptote at -3, horizontal asymptote at 2/5, and a 0 at 3. So let's go piece by piece. Let's do a hole at 1. So I'm going to call my function f of x. You can call it whatever. But I have a hole at 1, so parentheses are liars, so I've got x minus 1 over x minus 1. I'll change my handwriting here just to make it a little bit more clear. X minus 1 over x minus 1. And then I've got a vertical asymptote at 3. So vertical asymptote goes on bottom, and parentheses are liars. And then I've got a horizontal asymptote here at 2/5. So I'm going to want 2 and 5 in front. And for it to be a number, they have to have the same degree. Remember, lead over lead happens when it's the same number, like the same degree. So we'll see where we're at when we fill in our things. So boom. And then a 0 at x equals 3. So x minus 3. So when I look at this then, did they have the same degree? Yes, they're both. I've got 2 x's on top and bottom, so that fills all my needs.